So since 49 is a perfect square, the first one is a perfect square. The square root of 49 is 7. When you double it, you get 14. It's going to be a perfect square. Same thing here. Square root of 64 is 8. Double it is 16. This is the difference of two squares, plus and minus. Difference of two squares, plus and minus. And then the first and last term here were perfect squares, and the double of the sum added up to 40. So it was 5u plus 4, quantity squared. Talks about factoring. This is kind of a brief summary of how to factor, all right? And so at the very top of the page, it says, always look for the greatest common factor first. So that is always what you're going to do. On homework, I think your last one had a greatest common factor before you could do the plus or minus for the difference of two squares. And so you always want to see if there's something you can take out of every single term first before you start factoring. The next thing is, what type of terms do you have? You can have 2 terms, 3 terms, or 4 terms. All right, so in your quiz on Friday, they're all going to be mixed and matched together, right? So it's not going to be separated by types. And so if you have 2 terms, you want to look and see, do I have a special case? You have already looked to see if you have a common factor. We're on to looking at the terms now, okay? And so if it's 2 terms and it is subtraction, you want to see, are these perfect squares, where it's going to be like a plus b, a minus b. Difference of cubes, don't worry about that because we haven't gotten to that yet. We'll get to that later. If you have sum of squares right here, so if this is a squared plus b squared, you cannot do anything with that. All you can do is take out your common factor. 3 terms where the first one is a 1. When the first term is a 1, you only have to worry about the last term. Factors of the last term that get you to your middle, whether it's adding or subtracting. If there is a term in the front, they call it the rainbow method, where you multiply 2 times the -5, and then you rewrite it as a 4 term. 4 terms, that's how we factor by grouping. Group the first, group the last, take out the common factor, and then you will get your final factoring. So this is kind of a brief overview of what factoring looks like. All right, so now we're going to look at special cases. So perfect square trinomials will always look like this. The first term will be a perfect square, the last term will be a perfect square, and the middle term can be either plus or minus. All right? If it is like this first one, then your factoring is always going to be a plus b squared. If it's subtraction, it's going to be a minus b squared. All right? So when you do factoring like the 2 that they have given us, you would take the square root of the first one. So the square root of your 4x squared, which is 2x, and the square root of your b, which is 36, and decide if that is going to be positive or negative based on the middle term there. So 2 times 2x times 6 gives us a 24x, which is positive. So we're going to say 2x plus 6 would be my answer here. If I were going to do the subtraction one over to the right, the square root of a is 3x. The square root of b is 8. The middle term is negative. So I am going to end up having 3x minus 8 squared, because if I have negative 3x times 8 and double it, you would get negative 48x. So that would be your perfect square trinomials. Perfect square trinomial. Difference of 2 squares. Difference of 2 squares always has a perfect square, and it is always minus. Perfect square in the front and the last, and it is always minus. If it is plus, you cannot factor it this way, but it is minus. Then you can factor it, the square root of a squared, which is a, square root of b squared, which is b, and do it like that. So the first one, the square root of the first one would be 5x. The square root of the second one would be 9. So you would use both of those factors with plus and minus. The second one, let's look at this one. It's a little bit different. The square root of 16 is 4, but the square root of x to the 4th is x squared. All right, so 16 is a 4, but the x to the 4th is going to be x squared. The square root of 49 is going to be 7. So here you would say 4x squared plus 7, 4x squared minus 7. So go ahead and do that extra practice at the bottom. So perfect square trinomial would look like this. All right. B was the difference of two squares. Can you take anything out of it first? Yes or no? Can you take something out of this? Does something come out of 4 and 36? What does? A 4. So if you take a 4 out, what do you get? Squared minus what? There we go. That's hard to read, so we'll do it in a different color. That would be all your factoring. If you did 2x plus 6, 2x minus 6, you can take a 2 out of those. So you can take a 2 out of each one, which would be a 4. All right, you always look for a common factor first. All right, for the next one, this is also the difference of two squares. You cannot take anything out of this. So you would say 3x minus 8 and 3x plus 8. All right. All right. The last one, this was also a special case, perfect square trinomial, right? 4 has a square root of 2. 121 has a square root of 11. When you multiply 2 and 11, 22, and double it, you get the 44. So the square root of this is going to be 2x. The square root of this is going to be 11. You're going to get 2x. You're going to use that minus 11 quantity squared.